So we're going to take a look at a HashSet implementation today. So it's in NeetCode 250, and the question says, design a HashSet without using any built-in hash table libraries, the actual class you have to implement, and then 3 of the methods. It also states that the max constraint, or this is one of the constraints about the keys, and that at most 10,000 calls will be made to add, remove, and contains. So first of all, just to start off, what actually is a hash set? So it's simply an unordered collection of unique elements. It lets you instantly check whether something exists in the collection. You can add it to the collection, or you can remove it, all in the average case of O of 1. Is a small caveat. That's why it's average case or amortized. So the whole reason you don't have to scan the whole container to find or to add, etc., is the properties of the hash function. So we'll get into that once I start implementing it. But first of all, we're just going to make what's called a bucket. So it's an integer that's const, and call it bucket. This is going to be equal to 10,000, so the max that I read at the start. Then we are going to have the actual data structure that holds it. So it will be a vector of a doubly linked list. So this is a doubly linked list in C++ of integers, and I'm going to call this buckets. So it's a vector of lists that hold integer values, and I'll explain that now. So in a hash set, you have a hash function which maps one value to a different value to store it in. It should be one-to-one. However, there can be collisions, so two numbers could hash to the same value. To deal with that, you can use what's called the chaining rule. So in these individual buckets, you will have a list, and that list can contain values that hash to the same value. So you have two values, you just add them as one node, and if another value hashes to that same bucket, you can just chain it on in the list. So I'll show you now in the first set the constructor actually. Actually, I need to implement the hash function first. So I'll show you the simplest way I can think of implementing this. This can actually be const because I'm not changing anything here, but I just need to return the key, modular arithmetic, and then so modulus, the bucket. So it will provide something in the range of the bucket, even if the key is above 10,000, which it can be up to 1 million, as the question states. So that's the whole hash function. It just maps the key to the finite number of buckets that we have, stated also in the question. And that is it for the member functions and the member variables. So we're going to move on to the actual constructor. So we're just going to set buckets and initialize it to buckets, so 10,000. And that's all we need for that. So next we need to implement the add. So you're adding with a key, so the parameter is a key. So first you need to get the index into this collection. So the index will be an integer. So IDX is the standard way for that, for writing an index. Then you want to actually hash the key with the function we made earlier. And we are going to then loop over the list and int x in buckets using this index. So we're going to find the correct list in the vector, and we're going to look through it, and if x is equal to the key, so if any of them are equal to the key, it means it's already there. So then we are going to just return out of that. This is because a hash set has unique values. So as I said at the start, it's a collection of unique elements, or I think I said at the start anyway. If not, there you go. But then we need to deal with the case if you don't find it. So we actually need to add it. So using again the index, and we can use the API of pushing back. So push back the key. So that's it for this guy. So checking if it's a duplicate. If not, perfect, we can add it. If it is, we just need to return, and we don't actually need to do anything else with it. But now to remove, so we take in the integer key. Again, we need the index like we do always, and then we take the hash of the key to find that. Remove is actually quite simple. So we just get the buckets, the index, and we can just use .remove from this list. Doubly linked list has .remove. Pretty sure a singly linked list also does, but a singly linked list doesn't have pushback because it doesn't have a pointer to the last element. I'm pretty sure that's correct, but could be wrong. I'd have to check on CPP reference for a single linked list. So forward list, I think it is. So all we have to do here is it removes every instance of the key. Of course, there's only going to be one because it's unique in the list, and that is it for remove actually. So that's it. So we're hashing it, then removing it. So .contains is a bit different. There is no just .contains for the list. So what we're going to have to do is same again, find the index, same as always, of the key. Then we're actually going to have to iterate over the buckets with the correct index. And then what we're going to have to do is check if x equals the key. Quite similar to the .add. And we then, if it is there, so if it is there, we can actually just do it on the same line, return true. However, if it is not there, it will skip that line and it will return false. And that's all we need to implement for that. Let's see, there might be some syntax errors, but I don't believe there is. Perfect. And that is the whole solution for this question. I'd say it's definitely one of the simpler ways to implement it. I'm sure there's a lot more other ways here. That's the simplest way I can think of. Okay, that's it. Thank you.